Children, let's see. Indeed a very good sum. Quite good. What does this particular question says? In triangle ABC, midpoints of AB, AC and BC are P, Q and R respectively. Means P is a midpoint of AB, Q is a midpoint of AC, R is a midpoint of BC. AS perpendicular to BC, AS perpendicular to BC. Prove that PQRS is a cyclic quadrilateral. Now very first thing, when you have this particular question in your mind that it needs to be proved as cyclic quadrilateral, people are looking for circle. 50% of the crowd are looking for circle. Sir, there is no circle. So how can you prove it as a cyclic quadrilateral? If there were to be circle and if the quadrilateral has to be embedded in it with all the four vertices on the circumference, then do we need to prove it? Then it's by definition it's a cyclic quadrilateral. Understanding what I'm trying to say? If those who are thinking that there has to be some kind of circle, why? Because it's a cyclic quadrilateral, right? So if circle is there and a quadrilateral is embedded in it with all the 4 points on the circumference, then why to prove it? By definition it is a cyclic quadrilateral. So you shall never have a circle. Keep this in mind. Whenever they are asking you to prove it as a cyclic quadrilateral, you shall never ever have a circle, right? So now let's start. I'm going to give you the skeletal solution for the same. I'm going to give you the skeletal solution for the same, and then we move on to the main one. Children, P is a midpoint of AB, Q is a midpoint of AC, R is a midpoint of EC given to us. Can I say in triangle ABC, P and Q are the midpoints, therefore PQ parallel to BC? By what theorem? Midpoint theorem. You must have studied this midpoint theorem in your classes or lower classes. In your lower classes, you'll have studied midpoint theorem. P is a midpoint of AB, Q is a midpoint of AC, therefore by midpoint theorem, PQ parallel to BC. If PQ is parallel to BC, can I say PQ is parallel to BR? PQ parallel to BR. So the very first thing is what I'm going to do is PQ parallel to BR. Likewise, Q is a midpoint of AC, R is a midpoint of BC. On the same lines, can I say QR parallel to AB? Can I say QR parallel to PB? Can I? I can. So, what is quadrilateral PQRB? PQRB, it's a parallelogram. Why? Both the pairs of opposite sides are parallel. We have proved. We have proved both the pairs of opposite sides parallel. So, it's a parallelogram. It's a parallelogram. Now what? Now, can I say in a parallelogram, opposite angles are congruent. So angle 1 congruent to angle 2. So my skeletal solution starts now. Angle 1 congruent to angle 2. Opposite angles of parallelogram are congruent. Done? Now, AS is perpendicular to BC. AS is perpendicular to BC. So can I say this triangle is a right angle? Which one? ASB is a right angle? ASB is a right angle. How about point P? Sir, point P is a midpoint of AB. If point P is a midpoint of AB, then can I say SP is the median? Can I say SP is the median? What makes me say SP is a median? Because it's a line joining from the opposite vertex onto the midpoint of the base. We have one theorem. In your lower classes, you all have done this. In a right angle triangle, median drawn to the hypotenuse is half of it. In a right angle triangle, median drawn to the hypotenuse is half of it. So who is the median? PS is the median. Is half of the hypotenuse. Who is hypotenuse? AB. But already AP is equals to PB, which is half of AB. Or you can say even PB is half of AB. PB is half of AB. Why? P is a midpoint. P is a midpoint. Just now we said PS is half of AB, but PB is also half of AB. So can I say PS is equals to PB? Can I say PS is equals to PB? If I were to say PS is equals to PB in triangle PBS, If PS is equals to PB, is it an isosceles triangle theorem? Base angles are equal. Angle 1 congruent to angle 3. Angle 1 congruent to angle 3. Earlier I said 1 congruent to 2. Now I say 1 congruent to 3. So what can I say from this equation and this equation? Are 2 and 3 congruent? Therefore, angle 2 congruent to angle 3. Now what is angle 2? And what is angle 3? Can I say angle 3 is an exterior angle for quadrilateral PQRS? Angle 3 is exterior angle for quadrilateral PQRS? By converse of exterior angle property for cyclic quadrilateral, if an exterior angle is congruent to angle opposite to its adjacent interior angle, the quadrilateral is a cyclic quadrilateral. This is the first way. Sir, why did you say it's the first way? I have one more way with only one step in addition. With only one step in addition. With this exterior angle property also you can do so. And those who wanted to go with opposite pairs of, that is one pair of opposite angle to be supplementary. Those who had that in their mind, sir, can we prove it by one pair of opposite angle as supplementary? I can do with that also. With this done, I will not write down what I shall say. Let this be angle 4. So can I say let this be angle 4? So now can I say angle 3 plus angle 4 is 180? Angles in linear pair. But 2 is already congruent to 3. So instead of writing 3, can I say 2 plus 4 is 180? Now check what is 2 and 4. Are they opposite angle? Of quadrilateral PQRS, one pair of opposite angles are supplementary. Quadrilateral is a cyclic quadrilateral. Right? So don't you find that it's a very good sum? Indeed, it's a very good sum. So this is what our skeletal solution is. We are going to write down, based on this, the sum is quite big. Mind you, this sum is quite big. We are going to write down now the main solution. What is it? Our proof starts in this way. Our proof starts in this way. What is it? As I stated, points P, Q, R are the midpoints of AB, AC and BC respectively. Therefore, one by one with PQ, can I say PQ parallel to BC, and with QR, therefore by midpoint theorem, by midpoint theorem, what? PQ parallel to BC, that is PQ parallel to BC, that is PQ parallel to BR. BR is part of BC. Also, can I say QR parallel to AB, that is QR parallel to PB? Let me say this as equation 1. Let me say this as equation 2. From 1 and 2, can I say quadrilateral PQRB is a parallelogram? What is the reason behind it? By definition. Now when I say by definition, this is by definition, mind you. When I say by definition means what? We are telling the examiner that we have proved both the pairs of opposite sides parallel. We have proved both the pairs of opposite sides parallel. Therefore, it's a parallelogram. So what is the first our skeletal line? 1 to 2, 1 congruent to 2. So after writing these many steps, now we are reaching with the first step. Therefore, angle 1, and who is that angle 1? Angle PBR congruent to PQR. But since we have studied the skeletal solution, somewhere down the line, 1 needs to be equated with 3. So I'll write down that is PB and not R. We'll restrict with S congruent to PQR. And we shall give each one as equation. And over here, we shall just write down the collinearity, B dash, S dash, R. Any problem, children? We move on now with the next one. Since AS perpendicular to BC, AS perpendicular to BC, therefore triangle ASB is a right angled triangle. Point P is a midpoint given to us. I can say therefore segment SP is the median. Because point P is given to us as a midpoint, SP is a median. Therefore, SP is half of AB. SP is half of AB. Reason, this property is applicable only in right angle triangle, mind you. Whatever I'm going to write down and what I have written over here is applicable only to right angle triangle. In right angled triangle, median drawn to the hypotenuse is half of it. Median drawn to the hypotenuse is half of it. Also, we are aware since P is a midpoint, can I say PB is half of AB? Equation number 6, since point P is the midpoint of AB. Right? Now, what can we say from 5 and 6? So, let's write down our solution here. I'm sorry for this kind of arrangement, but since our solution is lengthy, we have to. From equation 5 and 6, what is it? Can I say it is SP is equals to PB. Equation 7. In triangle PBS, SP is equals to PB. From where did you get it? From equation 7. Therefore, is the base angle congruent? Angle PBS equal to angle PSB. Equation 8 by isosceles triangle theorem. By isosceles triangle theorem. Equation number 8. PBS, PQR. PBS, PQR. PBS, PSB. From equation 4 and 8. 4 and 8. What can I say? Can I say PSR is equals to PQR? I hope you have understood here via exterior angle property also. I can say at this juncture also I can say that quadrilateral is a cyclic via using exterior angle property. So I'm just marking it over here for you people. Via using converse of exterior angle property you can say, but we are moving one step further. So I'm giving you two answers. Now, what is angle PSB? PSB plus, so I have written over here PBS PSB is equals to PSB PBS PSB, no, it's PQR. I'm so sorry, it's PQR. PBS PQR. PBS PSB only. Here it is PSB and PQR here. Yeah, PSR with PQR. PSR PSR, no, PSB. PSB, because what is common is PBS is common. PBS is common, so PSB with PQR. PSB with PQR. I'm really sorry, this PSB with PQR. Now, what is PSB plus PSR? PSB plus PSR is 180. Reason, equation number 9. Reason, angles forming linear pair. Angles in linear pair from 8 and 9. What will I get? PSB is PQR, and then PSB plus PSR is 180. Instead of writing PSB, can I say PQR plus PSR is 180? Check, where is PQR? PQR, PSR. Are they forming opposite angle? Therefore, quadrilateral PQRS is a cyclic quadrilateral. What is the reason? Reason is what you need to write down. If in a quadrilateral one pair of opposite angle is supplementary, the quadrilateral is a cyclic quadrilateral. What is the reason? I want my children to write down. What is the reason? If in a quadrilateral one pair of opposite angle is supplementary, then the quadrilateral is a cyclic quadrilateral. If quadrilateral one pair of opposite angle is supplementary, if one pair of opposite angle is supplementary, then quadrilateral is a cyclic quadrilateral. Right, children? I hope you have understood the entire sum. Sure? That's it.